So in example number 3, we're asked to do the same thing, which is we want to solve the triangle, and we have B equals 4,157 centimeters, C equals 3,446 centimeters, and angle C is equal to 51.8 degrees. And once again, we're asked to round all solutions to the nearest tenth. So let's draw a triangle just to help us get it labeled. So we have A, B, and C. And let's label our sides. So side B is 3,446 centimeters. Side B, I labeled that wrong. Side B is 4,157. Side C is 3,446 centimeters. Side A we don't know, and angle C is 51.8 degrees. So then, if we look at our situation here, we have side angle once again. So side angle. And we want to take a look at this example. So if we look back at our sheet, we'd started filling in side angle on our sheet last time, and we want to add a couple of more things to this. So last time we did side angle, and we noted that there may be 0, 1, or 2 triangles. The method to solve is the law of sines, and it is also example 3 in 8.1. So we want to add that as well. And this time, I'm going to let the cat out of the bag. We're going to see an example that has 2 triangles. So the one that we did last time was the example where there were no triangles, and this is going to be the other extreme case, which is where there are going to be 2 distinct triangles. So the first thing that we need to do is the same as step 1 in the previous one. We need to solve for the unknown angle across from the known side. So in our case, we need to solve for B. Using the law of sines, so we're going to have the sine of angle B divided by side B, which is 4,157, is equal to the sine of angle C, which is 51.8 degrees, divided by 3,446, which is side C. So we solve getting sine B is equal to, by multiplying both sides of the equation by 4,157. And that reduces out the 4,157s, giving us sine B equals 4157 times the sine of 51.8 degrees all over 3446. So now, finally, the last thing we need to do is take the inverse sine of both sides. And that gives us the inverse sine of 4157 times the sine of 51.8 degrees all over 3446. So we need to solve this equation. So we grab our calculator and we ask it very nicely. And we say, what is the inverse sine of 4157 times the sine of 51.8 all over 3446. I press enter, and I get a domain error. So I'm going to choose quit, but it turns out there's really not a domain error here. We have to be very careful, and remember, they're in degrees. The reason I got that domain error because my calculator was in radians and not in degrees. So we go back and we try again. And this time, my calculator indeed gives me an answer. So this was in radians, not degrees. So that one we didn't want, and this is our correct answer. So we have to be a little bit careful. If we remember, the range of the inverse sine function went from negative pi over 2 to positive pi over 2. We can't have negative angles, so we're really in this problem only using the domain between 0 and pi over 2. But inside of a triangle, we can have angles that are bigger than 90 degrees. So we have to be a little bit careful. If we just put it into the calculator, it gives us one of those two angles. But remember, if we were to draw a picture, sine is positive in both quadrants 1 and 2. So we found our reference angle in quadrant 1, which is 71.44 degrees, but sine is also positive in quadrant 2, and we can have the same reference angle. So if that angle is 71.4 degrees, then the entire angle is 180 degrees minus the 71.4, which is equal to 108.6 degrees. So it's worth noting this angle is not in the range of sine inverse. If there is a second triangle, the second angle is always, so theta 2 is always 180 degrees minus theta 1. So if this is theta 1, then the other angle is its supplement, so 180 minus that angle. And this is the angle that is going to give us the second triangle. So now when we have to resolve this, we are going to have to actually solve two triangles now. So our first triangle is going to be the one that we started with, ABC, and we had 4, 1, 5, 7, 3, 4, 4, 6, and 51.8 degrees. Our second triangle is going to be the same triangle, but now we have our two different angles. So when we solved for C, or for B, sorry, in our first one, we got theta 1, which is 71.4 degrees for angle B. So we have 71.4 degrees. And then our theta 2 was the complement of that angle, which was 108.6 degrees. So now we need to resolve each of these triangles separately. So in both triangles, angle A is missing, but we know that angle A is going to be 180 minus the other two angles, 51.8 minus 71.4. And we do our subtraction, and we get 56.8 degrees. And then over here, we do the same thing. We get A equals 180 minus 51.8 again, but this time we minus 108.6 degrees. So in each of these cases, we are minusing the new angle B, which is different in triangle 1 and triangle 2. So then here we end up with A is equal to 19.6 degrees. So now, in both of these triangles, the only thing that is different is going to be, we have our angles and we have our sides. So we have angle A is different in both, and that is also going to force angle, or side A, to be different in both. And in each of these, we need to use the law of sine. So we're going to have A over the sine of 56.8 degrees is equal to C, which is 3,446, over the sine of C, which is 51.8 degrees. And so that gives us, if we multiply both sides of this equation by sine 56.8 and sine 56.8. Then on the left side, they reduce out, so that gives us our A. So we get 3446 times the sine of 56.8 all over the sine of 51.8. And we get 3669.23. So 3669. Or 3669.2. And then we rinse and repeat, and we do the same thing for our other triangle. And in fact, it's going to be exactly the same thing. We're going to have A over sine A, but our sine of A in triangle number 2, A is 19.6 degrees, is equal to, and we're going to have 3446 all over the sine of 51.8 degrees. Once again, we are going to multiply both sides by sine, but this time it's sine of 19.6. And our sines reduce out this time, and so we're going to get 3446, but this time times the sine of 19.6 all over 51.8, and we get 147096. Rounding to one decimal place, the 6 tells us to round the 9 up, which rounds to 10, so we carry the 1, so we get 1471.0. And that will be the second side A. So this was the example of side-side angle where we got two triangles. And we get the second triangle by taking the complement of the supplement of the first angle that we find and solving the resulting triangle. It is worth noting that it's entirely possible that when we try to do this, that we will only get one triangle, and that would be apparent if 180 minus theta 1 is such a size that when we go down here to solve for angle A, if angle A is negative, that second triangle wouldn't exist, because you can't have a negative angle in a triangle. All right. So the next one is for you guys. It's going to be a U try. Alright, so to do this U try, the first thing we're going to need to do, well, is sketch ourselves a nice triangle. So we have A, B, and C. We know angle A is 22 degrees. We know angle B is 108 degrees. And we know side A is going to be 10. So in terms of our chart, this one is actually one we haven't seen before. It was A on our chart, and I didn't explicitly do an example of this one. And so this is angle side angle, and we're going to use the law of sines to solve. And this is 8.1, you try number 1. And that is for our angle side. So the first thing we do when solving angle side is find the missing angle. And it is 180 minus 108 minus 22. So 180 minus 108 minus 22, and we get 50 degrees. So that gives us our angle C is 50 degrees. And then step 2 is we solve for the missing side. And we're going to have to do that twice. So we started off with A over sine A, so sine 22 degrees is equal to B, which is what we want, over the sine of 108. And if we multiply both sides by the sine of 108 degrees, those reduce out, and we get B is equal to, we have 10 times the sine of 108 over the sine of 22, gives us 25.38. So rounding to the nearest tenth, we get 25.4. And then we're going to have to rinse and repeat to find side C. So we go C over the sine of C, which is 50 degrees, is equal to A over sine A, so still 10 over the sine of 22 degrees. And this time we multiply both sides by the sine of 50. So we have 10 times the sine of 50 all over the sine of 22, not 2, 22. Press enter, and we get 20.44, so about 20.4 degrees. Or not degrees, just 20.4. What was it this time? Didn't say. So just 20.4 units. And that would be the solution to that for solving our triangle.